Record. So today we're looking at finishing up 1.6, and we're starting off with solving radical equations. And first step, if necessary, we want to isolate one radical to one side of the equation. Not sure why that's red. I must have left it out and just wrote it red. So we're going to isolate the radical, one of the radicals to one side of the equation. Second step, raise both sides of the equation to the power of the index of the radical. Step 3, solve the equation. If a radical still exists, then we'll repeat steps 1 and 2. Then step 4 is to check your solutions. And notice I put that we must check our solutions because it is possible that when we go about raising our powers, or raising our equation of both sides by a power, especially when we're talking about even power, we could have a solution that's not going to work for us. So we do need to check. All right, try to give you a chance to finish copying. All right. Okay, scroll up. Very good. Okay, so let's look at the first one. Square root of 2x minus 1 plus 2 equal to x. So we notice that the plus 2 is not under the radical. All right. So the first step here is to isolate the radical. So that means we want to get this expression on one side by itself. Okay. So what we'll do is subtract 2 from both sides. 2 will cancel on the left and leave us with the square root of x, 2x minus 1 equal to x minus 2. So that's just the end of step 1. That's not an answer, but just going step by step so you'll have a way to reference later on. All right. So next thing we want to do is to get the square, or get the radical, not the square, but get the square root, that radical off of our expression of 2x minus 1 so that we have access to the x. So we're going to square both sides, or raise both sides to the power of 2. The square and the square root will cancel on the left, leaving you with 2x minus 1. And then on the right is x minus 2 squared. All right. So let's go ahead and solve. And let me erase some stuff so we can walk through it. So x minus 2 squared, don't forget you can't square each term. You can't go x squared minus 4. You have to expand that out. That's x minus 2 times x minus 2. So we're over here with that expansion. And do your binomial distribution. You're talking about x times x times negative 2, negative 2 times x, negative 2 times 2. And so the result would be, the x squared minus 4x plus 4. All right. All right, so now we want to set one side equal to 0. We have a quadratic equation now. The x to the second power. Here, the highest exponent lets us know that. So we can subtract 2x and add 1 to both sides. 2x and that 1 will cancel on the left, which gives us x squared minus 6x plus 5. So then you can go ahead and solve that quadratic equation, whichever way you decide. Remember in last section, we talked about 4 different ways you can solve your quadratic equation. So I decided to use factoring, or the zero factor property, and that'll give me x minus 5 times x minus 1. All right. Set both parts equal to 0. Now we get the solutions of x equal to 5, x equal to 1. All right. So now before we go and check, questions.
The step where you did the factoring, what number is that? Step 4?
No, that's just that's a part of, I believe, step 3. Yep, that's just a part of step 3 in solving.
Okay.
Just solving the equation. Yeah. And step 4 is actually going to be us checking. All right. So before we go and check, any questions? Let's put 4 right here. All right, so we're checking both solutions, x equal to 5, x equal to 1. So on the left, plug in 5 into your original equation. So that's 2 times 5 minus 1 under the square root plus 2 equal to 5. So 10 minus 1 under the radical, which is 9. Square root of 9 is 3. Then 3 plus 2 is 5. And so that works out for us. But then if you look at the right side, plugging in positive 1, that gives us 2 minus 1 under the radical. Square root of 1 is just 1. 1 plus 2 is 3. And that would be 3 equal to 1. So don't forget, you plug in x. Plug in the solution wherever you see x. So the same thing happens over here. You plug in x in 2 different spots. And so we see that the 5, x equal to 5 works out. X equal to 1 does not work for us. We talked about before, solutions that do not work are considered extraneous. So our only solution would be the x equal to 5. All right. Problem before I go to the next one.
Could you leave it there for just 1 second?
Sure. Let me know when you're done.
Okay, I'm all good. Thank you.
All right, thank you. All right, looking at this next one, we have the square root of 3x plus 1 minus the square root of x plus 4 equal to 1. So first step is to isolate one of the radicals. So you make a decision. It doesn't matter which one you choose, but like I pointed out right here, since that has a minus sign in front of it, the easiest one to move would be that one, because we could add the square root of x plus 4 to both sides. All right. So that cancels here and leaves us with this equation. The square root of 3x plus 1 is equal to the square root of x plus 4 plus 1. And once again, make sure that radical does not extend, to the plus 1. The plus 1 is outside of it. All right. So coming down to the next step, we need to get that square root off of 3x plus 1. So we square both sides. That cancels the square root and square on the left side, leaving us with just 3x plus 1. And then on the right side, we are squaring the quantity of the square root of x plus 4 plus 1. So we haven't expanded that yet, but that's just the first results of squaring both sides. All right, everybody okay so far? All right, so we have to be careful with this next step. This right here gets a lot of people, so make sure we're cool. And if you have questions, of course, make sure you ask. So we have to do that same binomial distribution. Let me go back. The same one we did here, we have to do with this next expression. We have the square root of x plus 4 plus 1 times the square root of x plus 4 plus 1. And we have to do that same binomial distribution. So let me cancel out some of this stuff so we can walk through it. All right, let me write this better. All right, so when we do this first distribution, the square root of x plus 4 times the square root of x plus 4, you multiply what's under the radical, so we have the square root of x plus 4 squared. That's x plus 4 times x plus 4, which is x plus 4 squared. Then the square root of x plus 4 times 1 is just x plus 4. 1 times the square root of x plus 4, and then 1 times 1. All right. So now we can simplify this expression. We have the square and the square root right here that will cancel, and that will leave us with just this quantity, x plus 4. Then we can look at adding these together because there's a 1 in front of both. So the square root of x plus 4 plus the square root of x plus 4 is the square root of, well, it's 2 square root of x plus 4. And then, of course, we still have the 1 in the back. All right, questions on the result so far, and then we can combine the like terms. That 1 plus 4, which is right here. 1 plus 4 gives us 5. So we have 3x plus 2, 3x plus 1 equal to x plus 2 square root of x plus 4 plus 5. All right. So notice we still have a radical involved. And if you look at our steps, it says if a radical is still involved, we're at step 3 to go and repeat steps 1 and 2. So we need to isolate that radical, get that radical by itself once again. So I'm going to subtract x and subtract 5 from both sides so that they cancel out on the right. And I can simplify them into the expression on the left of the equation. So that'll leave me with 2x minus 5 equal to 2 square root of x plus 4. All right, questions before we go to the next step? All right, so the next step is to square both sides because I need to get rid of that radical on the right side. Square and the square root will cancel on the right, but also, and let me go back. Now, before I squared, what I could have done was divide each term by 2 because each one of them were divisible by 2. Chose not to because I want to emphasize this relationship right here. When I look at this square, because I have a 2 sitting on the outside of my radical, it's going to cancel out this radical, but it also needs to be distributed to that 2. So whenever you have that scenario, and let's say I couldn't cancel out divide by 2, this is what would have to occur. That square needs to be applied to that radical, and it needs to be applied to the number that's sitting on the outside of 2, or outside of the radical, excuse me. So the result of that would be 4. The result of that would be 4 times x plus 4. So the radical is removed, and then 2 squared is 4. Now on the left side, you have our binomial distribution. So you're talking about 2x minus 4 times 2x minus 4. And so you'll do your distribution. So that'll give us 4x squared minus 8x minus 8x plus 16. Combine your like terms, that'll be 16x in the middle. Distribute here as well. 4x times, well, 4 times x plus 4, so that'll be 4x plus 16. So we have these two quantities. So before we go any further, make sure we're okay. That'd be 4x squared minus 16x plus 16 equal to 4x plus 16. All right. So what I would do now is set one side equal to 0. So I will subtract 4x and 16 from both sides. So they will cancel out on that right side. Then on the left side, we notice actually 16 minus 16 cancels out as well. And our result is going to be 4x squared minus 20x equal to 0. So we can factor now. Take out 4x or factor out 4x from each term. That'll be 4x times x minus 5. And once I factor completely, set each part equal to 0. All right. Divide by 4. X equal to 0, and then add 5 to both sides. All right, those will be our two solutions. Questions? I think, yeah, we have to, I think I did go down and check, so we're good. All right, problems for our scroll. Okay. So right here is just to check. Remember I said we need to check both of our solutions, make sure that both of them work or find out whether one of them do not. And so we see here that 5 works for us and 0 does not.
On the homework, is it gonna ask us to do a check?
They're going to ask you for the solution or for the solve. So if you were to plug 0 and 5 in there, then they probably will mark it wrong. So you would have to check on it wouldn't tell you to check, but somehow you would have to validate, that 5 is right and 0 is wrong, because the only solution you would actually put in there should be 5. So, and
Okay.
and that's only for this process. You notice we didn't mention checking any all the way up to this point. But when it comes to this process, and this is 1.6, when you're dealing with these radicals, because you're going to be squaring both sides and stuff like that, that's when you have to check. All right. Questions before we look at the next one? All right. Can I scroll up? Someone still copying? So the next one, radical equations of the form x to the m over n power equal to k. So it says if m is even, so we're talking about, and I don't know if I even gave you enough time to write that, so sorry about that. But if m is even, the top number of your exponent, then you have a certain way of solving, versus if m is odd. All right. So in both cases, we're going to raise each side to the power of the reciprocal of the exponent. So, and I'll show you what we mean when we put numbers on it. But notice initially we have m over n, but then we raise each side to n over m. So you're going to flip the application of that power so that they'll cancel out. Same thing here, we have m over n, and we raise both sides to n over m. All right, so now if your numerator is even, then notice we have plus or minus, because what's going to happen is you're going to end up taking the even root, and the even root always produces two solutions, which is plus or minus. But if that top number is odd, you're only going to get one solution. So you do not do the plus or minus. So once again, I'll show you an example of that. Just want to make sure everybody's copied it down before I scroll up. Question, is everybody good? Scrolling up. All right, so just making sure we're okay with the application of the exponent being a fraction. If I have 8 to the 2 over 3 power to 2/3 power, it doesn't matter which order you apply this to the 8. You just have to remember that the denominator is always the root or the radical, and the numerator is always your power. So in this case, we have 8 to the 2/3. I can either take the cube root of 8 and then square it, or I can square 8 and then take the cube root. It doesn't matter which order I do it, I'm still going to come up with the same answer. It may matter if you're doing it in your head, because you'll be dealing with more familiar numbers versus other times. But if you're doing it in a calculator, it doesn't matter at all. So notice the cube root of 8 is 2, and 2 squared is 4. But if I were to square 8 first, which is 64, the cube root of 64 is still 4. So either way, you'll still get the same result, as long as you remember the bottom number is your root, the top number is your power. All right. So let's scroll up. So applying that thought process of solving with these radical exponents, we have 3x to the 3/4 power minus 81 equal to 0. So our top number, m, is odd. So don't forget, if m is odd, we're only going to have one solution. So look at what I did here. I added 81 to both sides because I want to isolate this x to the 3/4 power. I want to get that by itself. So I add 81 to both sides. 81's cancel on the left. And that will leave me with, I didn't need to do that, 3x to the 3/4 and equal to 81. All right. So now you still want to get this x to the 3/4 by itself. So you divide both sides by 3. And we have x to the 3/4 equal to 27. Now, according to what our steps told us, we want to raise both sides to the 4/3. All right, we're flipping that fraction that we have as an exponent. And so the reason being is because whenever you're raising a power to a power, you're multiplying. And that's what happens here. 3/4 times 4/3 is 12 over 12, which is just 1. So that simplifies our x down to just x to the first power. So we have x on the left, and then on the right, we have the cube root, not the cube root, we have 27 raised to the 4/3 power. So that means, don't forget, our denominator is the root, numerator is the power. So take the cube root of 27, which is 3, 3 to the 4th power is 81. And that'll be our solution. All right, any questions? All right, scrolling up. All right, so the next one, we have x to the 2/3 minus 3/4 equal to negative 1/2. All right, so once again, we want to isolate x to the 2/3 power. So we'll add 3/4 to both sides. And if we want to add those fractions, we need a common denominator. LCD would be 4. So we multiply top and bottom by 2. So that'd be 2/4, but negative 2/4, plus that 3/4, which would be 1/4. All right. So going back to our initial statement, don't forget our top number is even. So that means our result should have plus or minus according to our statement, our steps going in the beginning. So we're going to raise this x to the 2/3 to 3/2. Raise the 1/4 to 3/2. So 2/3 raised to the 3/2 power will cancel. End up giving us 6/6, which is just 1. Now this 1/4 raised to the 3/2 power. Don't forget your denominator is your root, numerator is your power. So we take the square root of 1/4 and raise it to the 3rd power. Don't know what was going on here. Oh, there was something I was telling somebody about. So the square root of, I didn't even need this over here really. The square root of 1/2 is 1/2. And then 1/2 cubed is 1/8. So our answer is going to be plus or minus 1/8. All right. Questions on that process? All right. And okay before we scroll up. All right. This next part of the section was dealing with equations in quadratic form. So here we have the initial equation of x to the fourth raised, or not raised, x to the fourth minus x 8x squared minus 9 equal to 0. And they say it's in quadratic form because when you look at this right here in comparison to your first term, this is that second term squared. And so that's what I wrote in this expression right here. Here we have x squared squared. X to the fourth is x squared squared. And then we have here x squared. So whenever you have that situation where you can rewrite the expression with those terms, the same terms, then this one is just being squared. That's considered an equation in quadratic form. So if you want to simplify it, you know, if it makes it look better, you don't necessarily have to do it this way, but you can let u be equal to x squared, just a u substitution. Wherein now we're looking at this as being our equation to solve. You decided to let u be equal to x squared. Whatever these terms are, you let u be equal to that. So now we have u squared minus 8u minus 9. All right. You can go ahead and factor that out. U minus 9 times u plus 1. Set each part equal to 0. U minus 9 equal to 0. U plus 1 equal to 0. So we have u equal to 9 and u equal to negative 1. So we're not finished, just because we got to, don't forget, we didn't start off with u. U is equal to x squared. But are there any questions getting to this point? So now you put u back, not u, but put x squared back in for u, where we had u equal to 9, now we have x squared equal to 9. And then we had u equal to negative 1, and we have x squared equal to negative 1 now. So to solve, you take the square root of both sides. And don't forget, we have to use the square root property whenever taking the square root of both sides. Square root of 9 is plus or minus 3, and then the square root of negative 1 will be plus or minus I. Those will be your 4 solutions. And don't forget, we had, going back here, 4 is our highest exponent. So we got our 4 solutions, even though 2 are imaginary. Excuse me. All right, questions? Any questions? All right, so the next one, this quadratic scenario, but a quadratic equation type problem is the same, even though we have different types of exponents. We have 5x to the 2/3 power plus 11x to the 1/3 plus 2 equal to 0. So that x to the 2/3 can be rewritten as x to the 1/3 squared, which puts us in position to have x to the 1/3 and x to the 1/3 here, just like we had that x squared. All right, so just like before, let u be equal to this part, x to the 1/3. And all right, so that'll be 5u squared plus 11u plus 2 equal to 0. Factor that out, that'll be 5u plus 1, u plus 2. Set each part equal to 0. And we have u solved for. All right, once again, we're not finished because we didn't start off with u, but any questions on how we got here? All right, so now we'll take x to the 1/3 and plug it back in for u. So we have x to the 1/3 equal to negative 1/5, x to the 1/3 equal to negative 2. Don't forget x to the 1/3 is the same thing as the cube root of x. So in order to get that cube root off of x, we will raise both sides to the power of 3. So that's what I did here. So I cubed both sides. That 1/3 power and the cube cancels, leaving you with x. And then negative 1/5 to the third power or cubed is negative 1 over 125. So cube both sides on the right side, and then negative 2 cubed is negative 8. Questions? Any questions? All right. Scroll all the way up. Good. All right, let me check one thing. I think this is the last thing out of this section, if I'm not mistaken. Yeah. Okay, so last thing out of this section, absolute value equations. So I think I made a mistake and wrote that there. Yeah. So if we're looking at the absolute value of 2x minus 3 equal to 11, and we want to solve that. So the way we would process it says if the absolute value of u is equal to c, then to solve for u, we would set it up as u equal to c, and then we want to solve for u equal to negative c. why we would do that is because we want to know when is 2x minus 3 equal to 11, and when is 2x minus 3 equal to a negative 11. Because remember, absolute value of 11 is 11. Absolute value of negative 11 is also 11. So that's what we're looking at here. And I probably should have did that right here instead of just putting 3's. You know. And so that's why we have to set this quantity equal to 11 and then set it equal to a negative 11. We want to know is when is 2x minus 3 equal to 11? When is 2x minus 3 equal to negative 11? And that's what we did here. Then to solve, we added 3 to both sides. Divided by 2. X is equal to 7. And x is equal to negative 4. All right. Questions on that process? All right. So here I have 5 times the absolute value of 1 minus x, 1 minus 4 plus 4x, excuse me. 5 times the absolute value of 1 minus 4x minus 15 equal to 0. So first thing you want to do is isolate the absolute value. So you want to get this absolute value of 1 minus 4x alone on one side of the equation first. So we'll add 15 to both sides. All right. Then we'll divide by 5. And we're looking at the absolute value of 1 minus 4x equal to 3. All right, so once we've isolated our absolute value quantity, now we can set 1 minus 4x equal to 3, and then 1 minus 4x equal to negative 3. Subtract 1 from both sides. Divide by negative 4. And we'll have our 2 solutions.
Mr. Tucker,
Yep,
is this the same one where we would have to check it to see which the actual solution is, or will both of them be the solution?
no, both of these should be fine.
Okay.
Yep. The only time we have to do that is when we have our radicals and we have to square both sides. Stuff like that. That's when we have to go back and check those.
Okay.
problems before I scroll up. Everybody okay? All right, so this next one, we have the absolute value of 3x minus 7 equal to negative 21. So we want to be careful here because we have the absolute value of 3x minus 7 equal to negative 21. And so whenever you solve your equation, you should be asking yourself, when is this statement true? And in this case, when is the absolute value of 3x minus 7 equal to negative 21? And so here, the answer is going to be never. Because remember, whenever you take the absolute value of something, the result will always be positive. So there's no way for the absolute value of 3x minus 7 to yield a negative 21. So really, when you have this type of problem, it's kind of like a trick question. So if you really start putting in work on this, it's like you're actually wasting your time because the absolute value can never be negative. The result of the absolute value can never be negative, and that means the answer is no solution. So always be careful with that. And remember, you can't make that declaration until after you've set your absolute value alone on one side of the equation. If you have other stuff that you need to take to the right and solve for, then you may not have a negative number. So make sure that you analyze the problem after you've solved or isolated your absolute value quantity. All right, questions. Oh, didn't ask. I meant to ask. Everybody done copying this before I switch? Everybody good? All right, let's see how much this is. And it's not that much, but all right. So we will, we'll stop right here and close out lecture on chapter 1 next class, because 1.7 is the last section in chapter 1. So I believe the way we're going to do this class is that, let me go to the review section. Yeah. The way we'll do this class is that, we got chapter 1, right? It's sections 1.1 to 1.7. And then you have your test. If I can write my stuff right. All right. So what I believe I'll do for you guys, I need to see when midterm is. So is that the first week in March? I'll look and see. The midterm week is first week in March, maybe second week in March. And so chapters 1 and 2 will probably be due midterm week. And I'll change the dates accordingly in my math lab. And then chapters 3 and 4 will be due, that final due date of when the class actually closes out. So Like I said, I'll find out that date and I'll put that in my math lab. Right now, just say, I believe all of it just say May. But chapter 1 and 2 will be due then, and then we'll go from there. So whether we're gonna have a midterm or not, I still haven't decided. I know right now test 1 should be posted, and you don't have to be proctored. You can just go ahead in there. It's not password protected or anything like that. And let's see what kind of time we have, to play with. Not sure if we just do test 2 proctored or if we do midterm, but as we get closer to closing out chapter 2, we'll talk more details. Supposed to have a midterm, but we'll work it out. We'll figure it out. But any questions on what we're doing about chapter 1? Chapter 1's test has already been posted, or it should be. If you don't see it, let me know. But it should be chapter 1 stuff is posted. I haven't changed the dates to the midterm week yet, but that's when chapter 1 stuff will be due. Now, keep in mind, all I'm doing is giving you room to, do your work and to operate, not telling you that I'm going to hold up lecture or pause or anything because you're only in 1.3. So remember, you're supposed to be progressing as we progress throughout the course with the lecture. With that being said, next class, we will do 1.7. And that'll be on Monday. And then Wednesday will be a review day. And you can ask whatever questions you want to ask on that day. And I will not do anything new next Wednesday. It'll just be a review. All right. So if you don't have any questions, then I guess you don't necessarily, no, I won't say that. I still want to make sure everybody's straight. So yeah, because I might say some things on Wednesday that pertains to the test. So yeah, come on Wednesday anyway. But yeah, we'll talk about 1.7 on Monday. Then Wednesday we'll do a review. How long the class will be on Wednesday will also depend on you because I'm expecting you to bring questions if you have them. Yeah, and we'll go from there. Questions. Everybody good? Everybody straight? All right. So with that being said, if you guys are good, I'm good. Have a great weekend. Be safe. And I will see you on Monday looking to close out chapter 1.
See ya.
All right. Thank you. Take care.
You too.
Thank you.
All right. Bye-bye.